Lesson 10, Chapter 1. We are going to compare real numbers. So the first thing you need to do is put the Venn diagram from your book in your notes. That Venn diagram looks like this, so let's talk about that for a little while. So first of all, this is the set of real numbers. I don't have room for the label up here, but this is all the real numbers. It includes rational numbers, integers, whole numbers, natural numbers, and irrational numbers. This is probably new to you. So let's talk about this a little bit. First of all, if you just pick any old number, sometimes people call them counting numbers like 1, 2, 3, 4, etc. Those numbers all go in natural numbers, okay? But that does not include the numeral 0. So 0 would have to go here in the whole numbers. It's whole, but it is not a natural number. If you picked like 10, 15, 20, any of those numbers, they have to go in this circle here because they are both whole numbers and natural numbers. And of course, they're also integers, and of course, they're also rational. That's the idea of a Venn diagram. Make sure you understand that. Okay, so then if we start taking negative numbers, then they have to go in here as long as they're a whole number with a negative symbol. That's an integer. If it's a fraction of a number, positive or negative, then it's going to go out into the rational. So negative numbers like -8, -3 would be integers. And of course, they're also whole and natural. And then lastly, anything that can be written as a fraction would be rational number, like 1/2 or 45/100. We could write that 45 over 100 rather than 0.45. Or negative fractions, -3/4, or 0.4 repeating, because remember, you relate to that as 4/9. You should remember that from the lesson before. So that's the rational numbers. Irrational numbers turn up when we have a number that does not terminate and does not repeat when we put it in a calculator. That's very important. If you put pi in a calculator and use the pi key, not 3.14, use the pi key and hit enter, and it will fill the screen. If it fills the screen, and it does, this will fill the screen, but it's a repeater. It's just all 4s. If you do 2 divided by 3 in a calculator, it will repeat. It'll be all 6s until the last one will turn it into a 7. You should recognize that that's the calculator rounding up the last digit when it does that. That is a repeater. 2/3 is a repeater. It's 0.6 repeating. Okay. This, as you can see, there's no pattern here, but it fills the screen. When you do this, this is actually the square root of 2. Put it in your calculator, the square root of 2, and it will give you this number here. Pi is another example. The square root of 3 is another example. Those are all irrational numbers. They do not repeat, and they do not terminate. They fill the screen. So they're going to give us some numbers, and we have to name all of the sets that that number belongs to. So for example, number 1, we have 0.2525. Clearly a repeater. Some of you might remember that we could rewrite that as 25/99. That obviously is a fraction, and that makes this one rational. Okay. Example number 2, we have the square root of 36. Now when we looked at this, we had square root of 2 and square root of 3 that were irrational, but just because it's a square root does not make it irrational. You have to evaluate it, and the best way to do that is put in a calculator for some of these. But this one we know in our head, that's the number 6. Well, the number 6, where does it belong on the chart? The number 6 belongs right here. It is natural, and because it's natural, it is also whole, it is also an integer, and it is also rational. Remember, going out, if it's here, it applies to everything. If it's here, it's only here, not here, 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 or here, etc. And if it's on this side of the line, it's only on this side of the line. If it's on that side, it's only that side. It's either irrational or something on this side, okay? It is all natural, whole, integer, and rational. Example number 3, we have the negative square root of 7. So put the square root of 7 in your calculator, make it negative, and it is 2.645751311. It fills the screen. It did not terminate. That's why we say it fills the screen, and it did not repeat. There's no pattern here. That makes it irrational. Please press pause and do letters A through C. In example number 4, we are being asked to compare the real numbers now. So we have the real number, the square root of 7, and we have 2 2/3, and we want to know greater than, less than, or equal to. So put this in a calculator, and you get 2.645. You get additional digits here, but usually you're only going to have to write down as many as, say, 3. I would guess. Okay, so write down your first three. This and a calculator. You shouldn't have to use a calculator, but if you need to, it's 2.6 repeating. We're going to put the 3 6s. And now we start comparing. The same here, and we're less than here. So the square root of 7 is less than 2 2/3. So you would put less than in your answer. Example 5. 15.7% and the square root of 2 1/100ths. Well, 15.7% you can multiply by 100, or what many kids do is they just move. You can divide by 100, or what many kids do is just move 2 places for the decimal point. So we have 0.157, so in other words 157 1,000ths, versus this in a calculator is 141 1,000ths. So clearly our answer is greater than. Example number 6. Order the numbers and then graph on a number line. So the first thing we want to do is here are our 4 numbers. This we could rewrite as 5.3, and I'm just going to put 3 6s there. It's a repeater, but that's close enough for now. This in a calculator is 5.5. This we can do this hopefully in our head and see that this is 80%, or 5.8, and this of course is 6. So now we're going to put these on a number line. So a good way to go about this would be by tenths. So it's 5.1, etc., all the way through 6. 6 is easy. We put a point right there and label that 6. And then this one here is 5.8. So we put a point right at 5.8 on our number line. And notice I'm still using 5 4/5. Do not write 5.8 there. Use the numbers you were given in these problems. Okay, you have to use the numbers you were given for your answer, both here and when you put them in order. Okay, then the next thing we're going to do is this is 5.5, so put it at 5.5, put the square root of 30, and lastly 5.36 repeating. So that would be 5.3, and the 0.6 repeating, if you think about it, that's 2/3. So 2/3 of the way from here to here would put us right there. Mark that as 5.36 with the 6 repeating. And then put your numbers in order. So you would have 5.36 repeating, square root of 30, 5 4/5, and then 6. Make sure you use the numbers they were given to label and to put it down here. You just use this to put them all in one common form in order to rank them. Please press pause and do letters D through G. Example 7. 1.23 times the square root of the distance from the ground in feet gives the distance that you can see on a clear day. So in other words, whatever distance you are from the ground, take the square root of that, multiply it by 1.23, and it'll tell you how far you should be able to see on a clear day. So Frida obviously was 1,250 feet up, so she could see 1.23 times the square root of 1,250, and Kia was 1,362 feet up, so this is her equation. Put this in a calculator, you get 43.49. This in a calculator, 45.39. And the question was asked, how much further can Kia see? So Kia's distance, 45.39, minus Frida's distance, 43.49, yields 1.9. So our statement would be Kia can see 1.9 miles further than Frida. If you haven't already done so, complete your letter problems. Here are your solutions to the Lesson 10 letter problems. First, we're being asked what set of numbers does this real number belong to? So we have the square root of 10. Put that in the calculator and you'll notice that it fills the screen. It does not repeat, it does not terminate, and that makes it irrational. Letter B, we have negative 2 2/5. Well, we could write this as a fraction. In fact, it's already pretty much a fraction, but we could put it as an improper fraction if we wanted to show that we can show it as a ratio. Since we can show it as a ratio, that makes it rational and only rational. Letter C, we have the square root of 100. Well, we can calculate that to be 10, and 10 is a natural number, which makes it a whole number, an integer, and a rational number, all 4. Next, we need to compare. We're comparing the square root of 10 and 3 1/3. 3 1/3 is 3 and 0.33 repeating, so I just wrote 2 of the 3's for now. And then I calculate this in a calculator and I get 3.16 rounded. and I can quickly see that that is a less than situation. Letter E, I have the square root of 17 and 4 and 3/100ths. And a calculator, I can find this to be 4.12. I just did the 2 digits just so I could compare quickly and easily. I can see that that is greater than situation. 12/100ths is greater than 3/100ths. Letter F, the square root of 6.25 is 2.5, and 250% is also 2.5, so we have an equal situation in this case. Letter G, we're now being asked to order the numbers and graph them. So here are our 4 numbers. First thing we do is decode them, and the best way to do that is put them all in decimal form. So we have -7. The negative square root of 60 is -7 and 74/100ths, just to the 2 digits for now. -7 and 7/10ths is -7 and 7/10ths. And -66/9 is -7 and 1/3, which is 0.3 repeating, so I just did it for 2 digits for now. So now we need to take and place those on a number line. So I started my number line, and this is a key thing for a lot of students. Have problems when we go with negative numbers on a number line. Remember, the numbers seem to be getting greater going that way. Because this is negative, it is really getting greater this way. So we start with -7.9, then -7.8, etc. And pick these at random. -7 we can place right away. Right here it's -7, label that -7. Then we have the negative square root of 60, we have to place that at 7.74. So right here is 7.7, and 4/10ths more would be 4/10ths of the way from here to here, going that way, remember, don't forget that. So that would be the negative square root of 60 would be right there. Next we're going to place -7 and 7/10ths. -7 and 7/10ths is right there. And lastly, -66/9, which would be -7.33 repeating. So 7.3 and another third of the way that way would be right here, -66/9. And then put, of course, our answer in order. So it's the negative square root of 60, followed by the -7 and 7/10ths, followed by -66/9, followed by -7. Please do guided practice.